My name's Bill Carey. My involvement in the classical school movement dates back really to high school. When I was in high school, my dad took a job teaching Latin at a classical Christian school. They couldn't afford to pay him, but he was so happy to have a place where he could teach Latin that he taught for free. It really worked out wonderfully for everyone involved. And I hung around the school helping out with its Latin club, so I got to know the students, the faculty, the founders of the school well. In high school, I was kind of split between two intellectual loves. On the one hand, math and science always appealed to me. On the other hand, I loved the humanities. When I went to college, I broke the humanities way. I majored in Latin, and when I graduated, what are you going to do with a Latin degree? I decided to teach high school Latin. And the school, Ad Fontes Academy, that I'd been helping with the Latin club, they offered me a job. So I interviewed with them, and during the interview they said, "How would you feel about teaching a calculus class too?" And it was my first job interview, and I didn't know anybody better, so I said, "Sure, I'd be happy to." There was a lot of prep work during the summer getting myself ready to teach that. So as I taught there over 5 years, my love for mathematics and science was really rekindled. And by the end of my time there, I was teaching calculus, physics, formal logic, as well as Latin and rhetoric. And my time there really brought into clearer focus how I'd been taught mathematics. I did well in math in high school. I took the AP calculus test and got a 5 on it. I did okay in college. I struggled more there. And what I came to realize was that the way I'd been taught calculus was a big cookbook. The way I'd been taught all of math was one giant cookbook of problems to solve. And I'd been taught particular techniques to solve each individual type of problem. So what I was good at was being a parrot, was identifying, here's this type of problem, I know the procedure to solve it, I'm going to do that. I'd gotten to the point where I could do that quickly, reliably, and efficiently. I started to run into some strain in college mathematics where, for the first time I was asked to solve problems where we hadn't gone over that exact type of problem in class, where I was asked to prove things. That was challenging because it was new, it was different, it wasn't something I'd been asked to do in high school. And that kind of stuck with me as I taught. Was I doing a good job preparing my students to deal with that, or was I just teaching them the cookbook? After 5 years, I decided that I wanted to know where math went. I wanted to understand what adults did with math. And to do that, I decided to get a job where I could work with people who were doing math all day at work. So I took a job programming computers with a defense contractor. The particular group I was in, we worked on making maps for the Army. And within that group, we more or less did math all day. We were writing computer programs that would automatically analyze images and other types of data and build them into maps. And it was all math. So doing that, I got a sense of how the mathematical work that adults do is different from the mathematical work that we ask our students to do in high school. On the one hand, the work that adults do is much, much more collaborative, right? Seldom do you see an adult asked to do a math problem and sent off on his own with no resources to simply do it and have it be right the first time. So it's not how things work. Adults make use of peer review, right? If you do some mathematical work, you show it to your colleagues so that they can look at it and say, no, you've gone wrong here, and then you take it and you revise it. So that's the second big thing about how adults use mathematics it's an iterative process, right? It's not this process where you do the math problem once and either it's right or it's wrong and you're done. You do the math problem, it's almost certainly going to be wrong in some way, and then you're going to revise it, you're going to fix the mistakes that you've made, you're going to improve it until it's better. Working there, I suppose I should say this too, I interned there for my last 3 years of teaching, so some of this worked itself into my last couple of years of teaching. Anyway, working there, I came to realize that the way adults use mathematics is much more like writing an English paper than anything that happens in a math class. Not only is it sort of an iterative and collaborative process involving drafts and revision and peer review, it's embedded in some context. And that, I think, is a vital point that I was certainly missing in my mathematical education. Adults seldom do math that's not connected to anything, right? If you're an engineer, someone's going to have asked you a question. Should we build a bridge here? You know, is it safe to operate this vehicle at this speed? Even accounting, you know, how many of these do we need to sell before we break even? The answer to those isn't going to be a number. Blast, for one of them it is. So hopefully we can edit this so that the last one reads, instead of, you know, how many of these do we sell? If we sell 100 of these, will we break even, right? The answer to those isn't going to be a number, right? It's going to be an answer that's embedded in the context of the question. As a high school math student, I didn't get any of that. I never had to place my mathematical work in a broader context. And I think that that's something that the classical movement does really well for the other subjects, right? To me, a lot of what the classical movement does is it builds an intellectual context, a broader intellectual context for the students. That is, it connects up the different parts of their intellectual world. We see how history and theology are related to one another. We see how science and history are related to one another. We see how these different disciplines interweave to produce kind of a coherent vision of the world. And then there's math sitting over on a little island off to the side, right? We don't weave math into that broader context. One of the things I was desperate for was to get a student to write a senior thesis where a significant chunk of their argument was mathematical. I could never pull it off. I never got anybody to do it. But I think with another couple of years, I'd be able to persuade someone to do that. Because just like anything else, you know, we use math as evidence in our arguments, right? Look at what's going on in politics right now, right? As we're debating the tax plans. If you don't understand the mathematics of what's going on there, you can't make a rational judgment about those plans, right? The mathematics is a key part of rhetoric, and we don't teach it that way. You know, we teach it off as this little island. And I think that's a terrible disservice to our students. I mean, goodness, look at American discourse. You know, the people on both sides of the political spectrum spout out all these numbers. Nobody's competent to evaluate whether or not they're any good, right? You know, the average American citizen can't follow their math and decide, you know, well, no, their math is bogus here, you know.
Or even know what questions to ask.
Or even know what questions to ask. So I think that, you know, much in the same way we teach rhetoric, you know, to prepare our students for a world where there is rhetoric, right? Where people will be making rhetorical arguments and the students need to be sort of able to defend themselves in that context. Goodness, if we're not teaching them how to embed math in their rhetoric, they're walking around with a huge blind spot that's just getting more and more important. You know, more of our arguments involve math somewhere in them. That to be able to embed math into a rhetorical context is absolutely important. It breaks the other way too. When we're doing math, you know, math is not a narrow road that you run down. Math is a big room. Someone described it. I want to say it's about Fermat's last theorem. Someone described it in a book. They said it's like a large room in the dark with lots of interesting objects in it, and you stumble around bumping into them and trying to figure out what the room looks like. That's much more what math is like. But again, we don't teach it that way. We teach it as this sort of mechanical process of moving from problem to solution.